Hi guys, my name's Lindsay, and today I want to take a few minutes to talk about logarithms and using the laws of logarithms to expand logarithms. So as you can see above my head here, I've got a couple single logarithms, and I want to take a minute and talk about expanding those logarithms. So let's take a look at this one first. We've got log base b of y divided by 8. So if I want to write that in expanded form, I'm actually going to assign a logarithm to each of these values, to the y and to the 8. And if you know your logarithm rules, which I hope you do at this point, you know that the division sign is paired with subtraction. So if I want to expand this, I'm going to write log base b of y. It's the first one, so I'm going to write the top one first. And then I'm going to write subtract, and then log base b again. I don't change the base of 8. So I've taken one single logarithm and I've pulled it apart. I've expanded it. And sometimes that comes in handy when you're actually solving logarithms that we can solve. Now in this case, we've got some variables, the b and the y. We can't go any further in that one, but it's been expanded. And let's do the same to this guy. This one, I have log base e. And maybe, again, if you're comfortable, you're used to seeing log base e written as ln, perhaps, but we'll leave it as log base e, just to show that the rules don't change no matter what the base is. So log base e of 17z. Now 17z really means 17 times z. Anytime a number and a letter are together, we're multiplying those, but the sign isn't always there. But it is there, it's just implied. So if I want to write this as an expanded logarithm, I'm going to write log base e of the first value I see, 17. And then I'm going to add that to log base e of z. Because again, in those rules, multiplication and addition pair together. And that's about as far as we can expand that one. Let's take a look at one more. And in this case, the only thing we can really do to expand this logarithm, to make it bigger, is this exponent up here. And again, hopefully you're comfortable enough to know that the rules say that instead of having an exponent up here, I can actually throw that exponent out front and multiply it by log base 10 of x. So log base 10 of x to the power 4 is the same as 4 times log base 10 of x. So that's sort of the three basic rules. We've done one for each type of rule. Let me make myself some room and let's look at a few examples that combine those rules in expanding logarithms. So now I want to take a look at two more questions, expanding logarithms, and this time just using the rules in combination. So we are going to start by breaking apart that the fraction that we have there and expanding it. We'll deal with the exponents at the end. We're kind of doing BEDMAS backwards in these questions. So we're going to start with the division and multiplication, and then again deal with fractions at the end. So what this says, log base b of x to the power 3 divided by y squared z. So I'm going to give each of them log base b of x to the power 3. And then this division sign implies subtraction. So I'm going to put the subtraction there, but I'm actually going to put a bracket now around these two because this x to the power of 3 is divided by not just the y squared, but by the z as well. And if I don't put a bracket there, then that negative is just going to be sitting in front of the y squared. I'll write it out and then we'll look at it. So let's write that log base b of y squared. And the y squared is multiplied by the z, so that's plus log base b of z. And again, the reason I wrote a bracket around these two guys is because both of them are on the bottom of that fraction, which means that this guy is divided by both of them. That negative should be sitting in front of both of them. I could leave my answer like that if I wanted to. Let's deal with these exponents. We know that when we're expanding, the exponents actually come out front. So I'm going to write a 3 in front of this log base b of x. I'm going to write a 2 out in front of this log base b of y. This guy doesn't have an exponent, so we'll just leave him alone. And if I wanted, I could finish my question off like that, but if I want my simplified question to not have any brackets, because a lot of the times when we're simplifying, we don't want those brackets in there, I could multiply that negative in. So I could leave this 3 log base b of x alone, but this negative would make the 2 log base b of y. It would make that one negative, but it would also make this guy negative. So if you want a final answer with no brackets, you want to make sure that you've multiplied that through the brackets. Because again, both of these were on the bottom, so they should both be negative. I'm going to grab a different color so you can see a little bit better, and we'll do this one. So again, we're breaking it apart. Let's do one step at a time here because we can. This says log base 5. I put a number in there instead of a variable. Doesn't matter. Rules work the same way. So log base 5 of x squared times y to the power 4. So I'm going to write x squared. And we know that multiply goes with adding. So added to the log base 5 of y to the power of 4. Now the z is the only one that's on the bottom, unlike this one. So z is going to be the only negative value. So there we have this fraction broken down. It's now 3 single logarithms rather than 1. And then to simplify one step further, or to expand one step further, we'll deal with these the exponents, which we'll throw out front. Plus log, we should have a 4 there, right? Because that guy should come out front. Log base 5 of y. No exponent here, so I'm just going to leave that one alone. And there you have the final answer. And hopefully that gives you a bit of an opportunity to understand using those rules in combination with one another.